This is Math 6 120, 37th trimestral. And our lessons for today is all about tangent lines, velocities, growth. So first, we have your D. In section 0.2, we estimated the slope of a line tangent to the graph of a function at a point. Okay? So I know you already encountered this one slope in your first module. Okay? At the same time, we have your D, the distance formula. At the end of section 0.3, we constructed a new function which was the slope of the line tangent to the graph of a function at this point. In both cases, before we could calculate a slope, we had to estimate the tangent line from a graph of the function. Okay? A method which records an accurate graph and good estimating. In this section, we'll start to look at more precise method of finding the slope of a tangent line which does not require a graph or any estimation by us. We will start with a non-applied problem and then look at the two applications of the same idea. Okay? So, by this time, we're going to have a slope, no? So, when we say slope, it refers to the uh, rise over run. Okay? And if you have already encountered this one in your analytic geometry or lower math, slope is equal to your delta y all over delta x, or y2 minus y1 all over x2 minus x1. Okay? When you say tangent lines, okay, when you say tangent lines, pag nalalaro po kayo ng volleyball, no? So meron kayong perimeter line po doon. Okay? At kung sakaling tumama yung bola po doon, so we will check on it if the ball is tangent or not. So parang ganun din po siya dito, no? So dapat makita po natin which belong to the tangent line. Okay? So the slope of a line tangent to a function and a point. Our goal is to find a way of exactly determining the slope of the line which is tangent to a function. Okay? To the graph of the function. At a point in a way which does not require us to have the graph of the function. Let us start with the problem finding the slope of the line L, which is tangent to the function of x, which is equal to x squared, at the point 2 and 4. We could estimate the slope of L from the graph, but we won't. Instead, we can say that the line through 2, 4, and 3, 9 on the graph of f is an approximation of the slope of the tangent line. Okay? And we can calculate that the slope exactly m is equal to delta y all over delta x is equal to 9 all over 4 divided by 3 minus 2 is equal to 5. Okay? So, dito po tayo dito sa figure 1. When you look on our figure 1, meron kayong x-axis and your y-axis. And then, meron tayong kulay pula po dito. So, if you're going to look on this curve, we have now a given function y is equal to x squared, or that is the same as x squared is equal to 4ay if you still remember your conic section. So under your conic section, we have your the parabola, the hyperbola, the ellipse, and the circle. Okay? So dito, since you have x squared is equal to y, so we are going to have a parabola which is opening upward. Pagbaliktad po naman siya, y squared is equal to x, ibig sabihin, with a parabola, opening to the right po siya. Pero pag negative, the opening will be downward or to the left. Okay? So, yung kulay red po dito, yan yung functions po natin. So, ang purpose po natin ngayon dito is to look for a tangent line. Okay? So, dapat yung tangent line natin ay mas palapit siya doon sa point of reference po natin. Dito, ang point of reference natin is your coordinates of x and y. At point 1, we have 2 for the x and 4 for the y. So, ito yung x natin. If x is equal to 2, by using this formula, y will be x squared. So 2 squared will be equivalent to 4. Okay? At your point 2, this your point 1, this your point 2, if x is equal to 3, ito na siya, no? 3 squared will be equivalent to 9. So therefore, this is your point 1, this is your point 2, and this will serve as your y2, and this is your y1. So we have your formula, m is equal to delta y all over delta x. Yung delta y po natin, magmula dito hanggang dito. At the same time, we call this one as your rise. Yung delta x po natin, magmula dito hanggang dito, that is your run. Okay? So, this will be your x2 and this will be your x1. So, therefore, if we're going to compute for this loop, for these 2 points, we have m is equal to 5. Okay? So, ganun po yung pag-compute ng slope po natin. Pero sabi dito, but m is equal to 5 is only an estimate of the slope of the tangent line and not a very good estimate because it's too big. So pag titingnan po natin yung point po natin mula dito, yung red line, yung curve po natin, saka yung black line natin, okay? So yung m is equal to 5, we call this one as your second line. Okay? Para hindi po tumutugma o kaya'y tangent dun sa curve po natin. Kaya sabi dito, it's too big. Kasi malayo po siya. Kasi pag curve yan, tapos gagawa ng straight line, parang may ano pa dito sa gitna nila. Okay? So sabi dito, we can get a better estimate by picking a second point on the graph of f which is closer to 2 and 4. The point 2 and 4 is fixed and it must be one point we use. From figure 2, we can see the slope of the line through the points 2 and 4 and 2.5 and 6.25. So sabi dito kanina, malaki siya, di ba? So it cannot be considered as along this way, we're going to have tangent lines. Pero dito, kumuha ulit tayo, binawasan natin, inilapit po natin siya. So from your figure 2, so your x by this time is 2.5. Nakasum lang tayo, kuha tayo sa gitna para ilapit po natin. So from your formula, y is equal to x squared. So 2.5 squared, your y will be 6.25. So by this time, this will serve as your y2, and this your y1, this your x2, and this your x1. And if we're going to compute for the slope, okay, 6.25 minus 4 divided by 2.5 minus 2, the answer is 4.5. So we have another second line, yung kulay black po dito. Okay? Pero, sabi dito, it's also a better estimate. But an approximation po ulit. So we can continue picking points closer and closer to points 2 and 4 on the graph of the function of f, which is equal to x squared. And then calculating the slopes of the line through each of these points and the point 2 and 4. Okay? So, dito, we're going to get points from the left and points from the right. From your points to the left, mula dito sa 2 and 4, bababa po tayo. Yung to the right, mula sa 2 and 4, akyat po tayo. Okay? So, pagpalagay natin, tapos na tayo sa 2.5, kukuha ulit tayo ngayon at 1.5. So, somewhere here, okay? Then, i-project po natin siya going up, project to the left, then you're going to have the value of your y, which is equivalent to 2.25. Okay? So, paano nakuha yung 2.25? If x is equal to 1.5 and the a squared po natin, 1.5 multiplied by 1.5, we're going to have an answer of 2.25. Okay? So by this time, this is your y2. Okay? Yung 2.25, this is your x2. And this is still your y1, and this is your x1. Using your slope formula, okay, your m is equal to 3.5. So somewhere along this point, no? 3.5. nandito siya, no? Okay? So, yung slope po natin. Okay? Dito, m is equal to 4, no? So, nandito yung slope po natin, 1.5 at saka 2.25. So, pag ganun yung slope po niya. Okay? Next, ilapit po natin siya, 1.9. 1.9 squared, that is 3.61. Okay? So, 3.9 uli, somewhere along this point, no? 1.9, ibig sabihin mas lapit siya. Nandito yung 3.9, so somewhere in this point. Okay? So, medyo ano pa rin siya, no? Malayo pa rin to be considered as tangent line along this way. So, we're going to get 1.99. So, your x squared is equal to 3.9601. And if we're going to compute for the slope, y2 minus y1, x2 minus x1, we're going to have an answer of 3.99. Okay, so medyo malapit na siya. Somewhere along this point. Okay? So next, we have the points to the right. Okay, nung una, we have 3 and 9. Pinakauna po natin, 3 and 9. Our slope is 5. Medyo malayo pa rin siya. Next, we have 2.5 and 6.25. Ito yung sumunod na ginawa natin. We have our second line, m is equal to 4.5. Medyo malayo pa rin. So, gagawin po natin, nilapit po natin. We have 2.01. Your y is equal to 4.0401. And if we're going to compute for the slope, we have 4.01. So, mas malapit na siya. Okay? So, sabi dito, the only thing special about x values we pick is that they are numbers which are close and very close to x is equal to 2. Someone else might have picked other nearby values of x. As the points we pick get closer and closer to the point 2 and 4 on the graph of y is equal to x squared, the slope of the lines through the points 2 and 4 are better approximation of the slope of the tangent line. Sabi niya, habang lumalapit po tayo dito sa point 2 and 4, dahil kinuha lang natin 1.99 sa 2.01 for this value, is a better approximation of the slope for the tangent line. And these slopes are getting closer and closer to 4. Okay? So, pag titingnan po natin, if we're going to make use of 1.99, siguro nandito siya, di ba? Tapos yung sa 2.01, nandito siya. So, along this way, from your 1.99 to 2.01, this point of intersections, okay, if you're going to connect that two points along this way, 1.99, 2, and 2.01, it realizes the location of the slope for the tangent line. Okay? So, dito, pag malayo po siya, ang tawag po natin doon ay second line. Pero pag malapit po siya doon sa point of reference natin, which is 2 and 4, and if you're going to connect that one, that's what we call the tangent line. Yung kulay blue po siya, which denote as L. That is your tangent line. Okay? So this is another example, no? Okay? So what is the loop of the line through 2 and 4? An xy for y is equal to x squared, and x equal to 1.994 and 2.003. Sabi dito, we can bypass much of the calculating by not picking the points one at a time. So let's look at the general point near point 2 and 4. Define x is equal to plus height or h. So h is the increment from 2 to x in our figure 3. If h is small, then x is equal to plus h is close to 2, and the point 2 plus h, the function of 2 plus h, is equal to 2 plus h, and then 2 plus h squared is close to points 2 and 4. Okay? The slope m of the line through the points 2 and 4 and 2 plus h squared is a good approximation of the slope of the tangent line at the point 2 and 4. Okay? So if we're going to look on our figure 3, This is now our point of reference. So meron tayong kulay red po ulit. So this refers to our given function, y is equal to x squared. So tulad po ng dati, if x is equal to 2, 2 squared is equal to 4. Ngayon, lalayo po tayo ng kaunti. Magmula dito hanggang dito, we're going to get that distance as h. Okay? So magmula dito hanggang dito, that is 2. Magmula dito hanggang dito, we have 2 plus h. So ito po yung sinasabi ko kanina na magmula dito hanggang dito, that is your rise. Okay? That represents your delta y. Magmula dito hanggang dito, that is your run, which represents your delta x. And then magmula dito, the point of intersection between the 2 points, if we're going to connect with them, then that's what we call the slope. Okay? So, may klase po ng slope po tayo, no? When we have a straight line, diba, tulad dito, our slope is 0 siya. Okay? Pag ang slope po natin ay vertical line, that is undetermined. Okay? Pag ang slope po natin ganito siya, we have a positive slope. Okay? Pero pag binaligtad po natin siya, pag slope natin ganito yung tsura niya, okay, pababa po siya, then we have a negative slope. Okay? So, halimbawa, if m is equal to negative 3, makikita po natin yung slope niya ay ganito siya. Pag positive 3, ang slope po natin ay ganito. Okay? Okay? So, yung h2 pa natin, 2 plus h, so magiging y2 po natin will be 2 plus h squared. Okay? So by this time, we're going to get their slope. Okay? Sabi dito, m is equal to delta y all over delta x. This is equal to 2 plus h and then squared. This sure, y2 minus y1. Then sunod, x2, okay, minus x1. So 2 plus h and then minus 2. Okay? So this time, we're going to simplify this one using the square of b binomial. So we're going to expand this one using the formula a plus b raised to 2. If we're going to expand that, we're going to have a squared plus 2ab plus b squared. Your a is equal to 2 and your b is equal to h. So 2 squared is 4 plus 2 times 2 multiplied by h. So we have 4h plus h squared. And then minus 4. Yung 2 dito at sa negative 2, magka-cancel na po sila. What's left is h lang po siya. And at the same time, yung 4 dito, negative 4, magka-cancel din po sila. So, natira, 4h plus h squared all over h. Okay? So, gagawin po natin, ipapactor natin po siya uli. Okay? H is the common factor. Itong dalawa, 4h, itong dalawa, h squared. By this time, makakancel yung h po dito. So, your slope that is equal to 4 plus h. So, yung slope po natin dito, yung kulay black, is what we call your second line, which is equivalent to 4 plus h. Okay? So, sabi dito, if h is very small, then m is equal to 4 plus h is a very good approximation to the slope of the tangent line. And m is equal to 4 plus h is very close to the value of 4. The value of m is equal to 4 plus h is called the slope of the second line through the points 2h and 2h, 2, 4, 2 plus h and 2h, 2 plus h squared. Okay? So, ito yung slope ng second line po natin. Ito na siya. Okay? Okay. The limiting value for of m is equal to 4 plus h. As h gets smaller and smaller, is called the slope of the tangent line to the graph of f at 2 and 4. Okay? So, balik po tayo dito sa figure 4 po natin. Okay? So, kanina, ang nasolve po natin na slope po natin ay second line, which is, okay. So, ang nasolve po natin na second line is 4 plus h, that is your slope. So, pag titignan po natin, hindi magkadikit yung kulay red saka yung straight line po natin, yung secant line. So, this is not a good, it's only a good approximation for the tangent line. Pero yung point dito, it cannot be considered as your tangent line. para makakuha po tayo ng tangent line, dapat yung mga points po natin, it should be closer to 2, no? Tulad po ginawa natin kanina is 2.01 saka 1.99. So, ganito din po, no? So, dito meron tayong point of reference, 1.994. Ibig sabihin, nandito siya, yung 1.994, saka 2.003. Okay? Somewhere in this point. So, if we're going to connect that one, we're going to have a line color in blue, which represents your tangent line. Okay? So, this one will serve as your x2, okay, or this one x2 minus x1, okay, you can compute your y2, 1.994 squared, the same with this one, okay. So sabi dito, ang tangent line po natin, dapat mas malapit siya lagi doon sa point of reference natin. To be considered, yung mga points doon as part of the tangent lines na madadaanan po niya. So dito, pwede natin maging tangent line is from 1.994 to 2.003. If you're going to connect that 2 points, you're going to have the value or the line for the tangent line. Okay? Okay, so we have here another sample last sample po for the tangent line. Okay? So we have here another sample, no? Find the slope of the line tangent to the function of x, which is equivalent to x squared at the point 1 and 1 by evaluating the slope the second line through 1 and 1, 1 plus x, the function of x, which is equivalent to 1 plus x. And then determining what happens as x gets very small in figure 4. So solution, they slope the second line through the points 1 and 1 plus h, and the function of 1 plus h is, so this is our figure 4. Pag titingnan po natin ngayon, our point of reference is 1 and 1. If x is equal to 1, 1 squared is 1 pa rin. Okay? So, tulad po ng dati, magkaroon tayo ng increment which is h. Ito yung rise po natin. Tapos yung run po natin, if this 1 plus h, your y will be 1 plus h squared. So this will be your y2 and this will be your y1. This will be your x2 and this will be your x1. So your delta y will be 1 plus h squared minus 1. Ito na siya. And then your delta x is equal to 1 plus h minus 1. So yung minus 1 dito, cancel siya. H na lang po yung natira. Okay? So, next, we're going to make use of the square of b binomial, a plus b raised to 2. So, we have a squared plus 2ab plus b squared. Ito na po yan. Okay? Our a is equal to 1, our b is equal to h. So, 1 squared is 1 pa rin. So, if we're going to simplify that 1, 1 minus 1, cancel na rin, no? So, natira will be 2h plus h squared all over h ulit. So, next, common factor sa numerator is h. So, 2 plus h, siya yung matitira. Yung h at saka h, makakancel. So, your slope by this time, we have 2 plus h. So, this slope is what we call your d, the slope of your second line. As h gets very small, the value of m approaches the value 2, the slope of the tangent line at the point 1 and 1. Okay? So, ibig sabihin nun, dapat if you're going to locate for the tangent line, you can have at least nearest dito sa point of intersection po natin or the point of reference. You can have 0.99 or 1.001. Okay? And if you're going to connect that one, then you can have your D, L, or D tangent line. Okay? So, ang tangent line po natin is yung mas malapit doon sa point of reference natin. Kasi pag lumayo siya, nandito, hindi siya pwedeng considered as tangent line. Tulad din sa volleyball, yung tinamaan ng bola, kung sino yung pinakamalapit, we can consider that inside or outside. Pero within that area, doon sa perimeter line po natin, okay, kung kung gaano siya kalapad, then we can say all points there are part of the tangent line. Okay? So, ang tawag po doon sa mas malayo na hindi tangent line, ang tawag doon is second line. Yung approximation lang po natin. Pero to make it exactly, ang gagawin po natin, dapat ilapit lang po natin siya dito. Tulad po yung ginawa natin doon sa example number 1. Okay? So next, we are going to proceed to uh, velocity. Okay? So tatlong lessons po tayo ngayon, the tangent lines, velocity, and growth. Okay? So next, you have the example for the velocity. We have the falling tomato. Sabi dito, suppose we drop a tomato from the top of a building which is 100-foot building. And the time is fall. Okay, from our figure 5, nandito na siya. Then meron tayong table po dito. Okay? The time in seconds for the first column and the height. Okay? So, nandito siya. May isang lalaki. Okay? Nag-ano siya ng tomato. Then, from 100 feet, okay? After 2.5, yan ay nasa ground na po. Okay? So, pag titingnan po natin yung first column natin, we have a common difference of their time interval. 0.5, 1, 1.5, 2.0, 2.5. Pero yung paghulog po niya, parang hindi siya uniform. Dito, uniform yung interval po natin. Pero dito, hindi. At 0.5, we have 96, 1, 84, 1.5, 64, 2, 36, 2.5, nasa ground na siya. Okay? So, ang alam po natin dito is that sa mga free-falling bodies, habang nasa taas po siya, medyo mabagal pa po siyang bumagsak. Pero, pag malapit na po na siya doon sa ground because of gravity, okay, mabilis na po siyang bumulusok pababa. Okay? That is your free-falling bodies. Okay? So, we have here so many questions, no? Questions letter A, how long did it take for the tomato to drop 100 feet? Okay? So, if we're going to look at our figure, magmula dito hanggang dito, gano'n raw siya katagal. Okay? So, we have a total of 1 hanggang dito. The total height is 100 feet. Ito na po siya, no? How long? It will take 2.5 seconds. Okay? Next, how far did the tomato fall during the first second? Ito na yung first second nila. Magmula dito hanggang dito. Gano'n raw siya kalayo pagkatapos ng isang segundo. Okay? So, after 1 minute, nandito na siya, 100 minus 84. 100 minus 84, the answer is 16 feet. So, yun po yung layo niya after 1 second. Next, letter C, how far did the tomato fall during the last second? Okay? So, from our figure, after 1 second, no, before it will hit the ground, 2.5, ito yung 1.5. Gano'n raw siya kalayo? 1 second before it will hit the ground. Okay? So 1.5 is 64, 2.5 is 0. So the answer is 64 feet. Okay? Next, letter D. How far did the tomato between t is equal to 0.5 and t is equal to 1? Okay? Gano'n raw siya kalayo sa 0.5 at saka 1 yung tomato po natin. So by looking at your table, 0.5 at saka 1. So we have 96 minus 84. Ang layo po nung dalawa yan is 12 feet po. Okay? Nandiyan po yung sagot. Okay. Next, another question. Sabi dito, some other questions require a little calculation. What was the average velocity of the tomato during its fall? So formula po natin, distance fallen all over total time. Or the change of position all over the change in time. So your answer is 100 all over 2.5. So the answer is 1940 feet per second. So ito yung average velocity nung ano natin, yung tomato po natin. Kaya pag titingnan po natin dito, mabagal po siya, pero pagdating dito, mabilis po siya. Pero ang hinahanap po nila is gaano siya kabilis matapos yung 100 feet after 2.5. So we're looking for the average velocity. So your answer is negative 40 feet per second. Yung negative dito only implies the direction is going down. Okay? Next question. What was the average velocity between t is equal to 1 and t is equal to 2 seconds? Okay? So t is equal to 1 and t is equal to 2 seconds. 1, mula dito hanggang dito. Ano raw yung average velocity niya? So pag titignan po natin yung distance at 1 second, we have 84. At 2 seconds, we have 36. So 36 minus 84 all over 2 minus 1. So negative 48 all over 1, the answer is negative 48 feet per second. So mabilis po siya doon. From 1 second to 2 seconds, the average velocity is negative 48 feet per second. Okay? Next, some questions are more difficult. How fast was the tomato falling 1 second after it was dropped? The question is significantly different from the previous two questions about average velocity. Here we want the instantaneous velocity, the velocity at an instant in time. Unfortunately, that tomato is not equipped with a speedometer, so we'll have to give an approximate answer. Next, one crude approximation of the instantaneous velocity after 1 second is simply the average velocity during the interval, which is negative 40 feet per second. But the tomato fell slowly. Ito yung ano natin, no? At the beginning. So, mabagal siya nung una. Pero mabilis na siya near the end. So, the negative 40 feet per second estimate may or not be a good answer. Dahil hinahanap po natin, after 1 minute, no? Gaano raw siya kabilis dito bumagsak. Okay? Kasi kanina, kinuha natin yan dito, tapos kinuha natin magmula dito hanggang dito. Pero ang kinukuha natin ngayon, magmula dito, then babagsak siya. Okay? So this now ano, we can get a better approximation of the instantaneous velocity at t is equal to 1 by calculating the velocities over a short time interval near t which is equal to 1 second. So the average velocity between t is equal to 0.5 and t is equal to 1. So para makuha yon, gagawin po natin, dahil ito yung area ng concentration natin, kunin natin itong dalawa dito, magmula dito hanggang dito, susunod magmula dito hanggang dito, para makuha yung average velocity niya, yung pagbagsak dito. Okay? So, we have negative 12 feet all over 0.5, so we have negative 24 feet second. So, mabagal po siya. Magmula sa dito hanggang dito, we have 24 feet per second. Pero sa baba, and the average velocity between 1 and 1.5, negative 20 all over 0.5, the answer is negative 40. Okay? So, magmula dito is negative 24, magmula dito is negative 40. Okay? So we can be reasonably sure that the instantaneous velocity is between negative 24 feet per second and negative 40 feet per second. So yan po yung sagot po natin. Okay? Next, we're going to look on our figure 6. Ito na siya. In general, the shorter the time interval over which we calculate the average velocity, the better the average velocity will approximately the instantaneous velocity. The average velocity over a time interval is the change in position all over change in time, which is the slope of the second line. So yan po yung nakuha natin na una kanina, that is your second line. Through 2 points of the graph of height versus time in our figure 6. The instantaneous velocity at particular time and height is the slope of the tangent line to the graph at the point given by the time and height. So we have the average velocity is equal to change in position all over the change in time. The average velocity is what we call the slope of the second line, wherein the instantaneous velocity from negative 24, okay, to negative 40, okay, is that what we call the slope of the line tangent to the graph. So tulad po dun sa example po natin ng una, dun sa tatlong na tangent line, dapat yung tangent line natin ay mas malapit siya doon sa point of reference po natin. Okay? So if we're going to look on our figure 6, okay, this is now the height of the building, which is 100 feet, and this is now the time interval. Okay? So nung binato natin yung tomato, after 2.5 seconds, nasa ground na po siya. Okay? Tapos nung una, nag-calculate po tayo na between 1 to 2, okay, hanggang dito, no? Pero kinumpute po natin between 1 and 1.5, ito na siya, no? Times 1 and 1.5, dahil is 84 and 64, meron tayong m is equal to negative 40. So ito yung average velocity po natin, which is negative 40. Ang tawag po doon, pag titingnan mo natin, malayo po siya doon sa given function. Yung dashed line po natin ng kulay black, hindi siya tumutungtong o kaya hindi siya dumidikit doon sa functions po natin na kulay red. So that is negative 40 feet per second, but this slope is what we call the slope of the second line. So yung instantaneous velocity po natin, nag-start po siya magmula dito hanggang dito. From 0.5 to 1.0 second for a distance of 96 to 84. So magmula dito hanggang dito, we have the tangent line or the slope of the tangent line, which is equal to negative 24 feet per second. So ganun po yung pagkuha ng tangent line. Dapat mas malapit siya doon sa point of reference po natin. So pag titingnan mo, parang kumonekta siya doon sa kulay red. Pero pagdating dito, parang medyo malayo na siya. So dito naman, sa second line natin, walang problema. This is another point of reference. Okay, so we're already done with your velocity. Okay, next lesson, we're going to have your growth. Okay, ito na yung last lesson natin. Sabi dito, suppose we set up a machine. So we have a growing bacteria, no? Suppose we set up a machine to count the number of bacteria growing on a Petri plate. Okay? At first, there are few bacteria, so the population grows slowly. Then there are more bacteria to divide, so the population grows more quickly. Later, there are more bacteria and less room and the nutrients available for the expanding population. So, the population grows slowly again. Finally, the bacteria have used up most of the nutrients and the population decline as bacteria dies, no? So this is now our figure 7. Your vertical line represents the population of your bacteria. And your horizontal line represents the number of days po dito. And this is now the growth of our bacteria. So pag titingnan po natin, nung una, medyo kaunti pa siya pero mabilis dumami. Okay? Hanggang habang dumadami siya, wala silang space dahil ito lang yung space nila at wala na silang pagkain. Nung na-reach nila yung peak number nila, that's the time na unti-unti na silang umuunti, okay, namamatay hanggang malis na yung after 18 days, ubos na po sila lahat. Okay? So yan po yung figure ng growth ng bacteria po natin. So, the population graph can be used to answer a number of questions. Okay? So, letter A, what is the bacteria population at time is equal to 3 days? So, ito po yung unang tanong. Gaano raw karami yung bacteria ng anak pagkatapos noong 3 araw? So, this is our first day, this is our second day, and this is our third day. So, paano natin malaman kung gaano siya karami? Project it to the project upward, okay? Then project it to the left. So, pag titingnan mo natin, approximately, nasa gitna ng 0 and 1. So, we can have, after 3 days, we have already a total of 500 bacteria. Okay? Next, pangalawang tanong. What is the population increment from t is equal to 3 days to the t is equal to 10 days? So, gaano raw kabilis dumami yung mga bakterya pagkatapos ng 3 araw hanggang 10 araw? Okay? So, doon sa 3 days, okay, meron na tayong 500, di ba? Pero hindi yun ang hinahanap. Ang hinahanap, magsimula sa pangatlong araw hanggang sa pang-10 araw. So, if you're going to project that one, 10th day, okay, project it upward, and then project it to the left. So, meron tayong nasa gitnang 4 and 5, approximately we have 4,500 after 10 days. Kaso, ang hinahanap lang natin dito pagkatapos nung pangatlong araw. So, hindi na natin sasali yung 500 dito dahil di na po siya kasama. Mula 3 hanggang 10, so 4,500 minus 500, the answer is 4,000 bacteria. Okay? Pero yung pinaka-peak nila, 10, 11, 12, 13. Parang nandito siya, no? So, ito yung pinaka-peak nila wherein their total population is 5,000, no? After 5,000, unti-unti na silang bumaba hanggang naging 0, no? Okay? So, pag titingnan po ninyo, mas mabilis namatay yung mga bacteria. Kasi within 13 days, buhay sila, that is 13 days. From 13 to 18, it's only 5 days, ubos po sila lahat. Next, letter C. What what is the rate of population growth from t is equal to 3 to 10 days? So ito po yung tanong ngayon, no? Gaano raw kabilis? Rate. So per unit time po tayo. Pagmula sa 3rd day hanggang 10th day. Doon sa 10th day, meron tayong 4, 5. Okay? Pero doon sa 3 days, ibabawasan natin. So we have 4,000. From 3rd day to 10th day, we have 7 days. So 4,000 divided by 7 dito. Okay, sabi dito, solution. Okay? The rate of growth from t is equal to 3 to t is equal to 10 is the average change in population during that time. The average change in population is equal to the change in population all over change in time. Is equal to delta population all over delta time. So yung change population niya for a period of 7 days, we have 4,000. Gaano katagal? 7 days. So yung rate ng pagdami ng bacteria from 3rd day to 10th day is 570 bacteria per day po. So paano nakuha yung 570? Dito, no? Yung 4,000 divided by 7. So you're going to have 570 bacteria per day. Okay? So this is the loop of the second line through the 2 points. So gagawin po natin siya ng figure ulit para may apply po natin yung tangent lines. So 3, 5, and 10, and 4, 500. Okay? So ito yung point of reference natin, yung pinakauna after 3rd day. Okay? So yung 3rd day po natin, number of days is 3, yung population natin is 500. Doon sa 10th day, ito po yun. Okay? So yung population natin doon is 4,500. Okay? So which means this is your y2 and this is your x2. This is your y1 and this is your x1. Okay? Pag kukunin natin yung slope na dalawa, using our formula, y2 minus y1, 4,500 minus 500, we have 4,000. Okay? 10 minus 3, we have 7. So our slope, that is our second line, is 570 bacteria per day po. Okay? So na-apply natin yung second line. Pero pag titingnan po natin yung second line po natin, it's only a good approximation, no? Hindi niya tinutumbok yung functions natin na kulay red. Doon sa growth rate po natin. Okay? So we are looking for the tangent line. So dito, what is the rate of population growth on the third day at t is equal to 3 days? Ito. Ano yung population growth niya after on the third day? Okay? Sabi dito, solution. This question is asking for the instantaneous rate of population change. The slope of the line which is tangent to the population curve at 3,500, if we sketch a line approximately tangent to the curve at 3,500 and pick 2 points near the ends of the tangent line segment, we can estimate that instantaneous rate of population growth is approximately 320 bacteria per day. So by this time, yung average population doon, pag kinuha mo yung slope niya, ang tawag doon ay slope ng second line. Yung instantaneous population growth rate, pag kinuha natin yon, ang tawag doon, that's now the slope of the line tangent to the graph. Ang sagot po dito is 570 per day siya, pero doon sa tangent line po natin, ang sagot po niya is 320 bacteria per day. So pagbabalik po tayo dito, yung ano po natin dito sa figure po natin, if this is our point of reference, so yung ano natin, magmula dito hanggang dito, we can have now the point of reference for our tangent line. Okay?